Hi Bobcats! In this video we're going to start our study of Chapter 10, which is all about covalent bonding. Our first objective will be to describe covalent bonding as sharing a pair of electrons via orbital overlap. We've got a slide further down that's going to show exactly what we mean by orbital overlap, but the basic idea is simply that if two orbitals from two different atoms spatially overlap, then the electrons can occupy both orbitals at the same time, and then those two atoms will share that pair of electrons. The reason that a bond will form between two atoms is that those two atoms bonded together will have a lower overall energy than those two atoms being separated from one another. It's all about energy and finding that lowest energy position. A general rule that we have for making predictions about bonding is known as the Octet Rule, and it says that atoms will share or transfer electrons to achieve 8 valence electrons, which are referred to as being an octet. Ionic bonding happens when they transfer the electrons, and that's what occurs between a metal and a nonmetal, whereas covalent bonding is what happens when electrons are shared, and that usually happens between a nonmetal and another nonmetal. But here's where that octet comes from. 8 electrons are going to be arranged in these subshells. So whatever your highest energy level is, we'll call that N. We're going to completely fill the S and P subshells, so NS2, NP6. So 2 plus 6 gives us those 8 electrons. And that electron configuration looks just like a noble gas, which we already know to be a very stable, low energy electron arrangement, which is why the noble gases generally don't undergo chemical reactions. I'd like for you to think about covalent bonding from the perspective of these two isolated atoms. Now, what's going to happen if those atoms start getting closer to one another? So there it goes. It's getting closer and closer and closer until their orbitals overlap. Now at this point, since their orbitals are overlapping, the electron in one atom is also occupying an orbital in the other atom, and that's going to give us a shared pair of electrons. And normally those overlapping orbitals are drawn something more like this. And here's the cool thing. The physical basis of this bond is that those negative electrons that are shared are attracted to the positive nuclei in both atoms. That's the glue that keeps these atoms stuck together in this chemical bond. That shared pair of electrons is attracted to both nuclei. The concept of sharing a pair of electrons to form a covalent bond is one type of bond on a continuum of bonding. So there we go with our what we call pure covalent bonding. Sometimes you'll see this notation with pure out in front. Sometimes it'll just be referred to as a covalent bond. And what we mean here is that the pair of electrons is evenly shared between both atoms that are involved in the bond. Another type of bonding is polar covalent bonding. Here we're still sharing a pair of electrons, but now they're unevenly shared. One of the atoms pulls on the electrons more strongly than the other atom does, so the electrons tend to spend a little bit more time around that atom, and we indicate this by this symbol right here. The Greek letter there, that's the lowercase Greek letter delta, and so that delta minus means that there's a partial charge. Over on the other side, where the electrons are spending less time, we have a partial positive charge, simply because the electrons are slightly absent from that side. This charge is not a full charge unit. It's going to be a fraction of a charge unit, and normally we don't specify a number with it. It's just smaller than one complete charge unit. The other extreme of this bonding continuum is ionic bonding. And so imagine that in our polar covalent bond, that atom on the right that's slightly negative, Well, if instead of still pulling the electrons towards itself, but still sharing it with the other atom, what if it pulled the electrons so strongly that it completely separated away from the atom on the left, giving a negative ion? That's what happens here with ionic bonding. We have an atom that pulls that electron away from the other atom, the atom where it's missing, it will have a positive charge. And so when this happens, we say that the electrons have transferred and we formed an ionic bond. Also, in terms of vocabulary, both a pure covalent bond and a polar covalent bond are considered covalent bonding, right? Whether it's a pure or a polar bond, it's still considered a type of covalent bond, and it involves sharing of electrons. It's just in the case of a pure bond, a pure covalent bond, those electrons are shared evenly, and in the case of a polar covalent bond, the electrons are shared unevenly. They spend more time around one atom than around another. So our objective for this video was to describe covalent bonding as sharing a pair of electrons, and the physical mechanism that this happens by is orbital overlap, when the two atoms are close enough to one another that the electrons occupy orbitals from both atoms simultaneously.